Hello, my name is Oscar Venter, and I lead the Conservation Solutions Lab at the University of Northern British Columbia, Canada, where we work to provide solutions to complex conservation problems. We've been working with the United Nations Development Program to develop the essential life support area proof of concept where we're using systematic conservation planning. So in the next 20 minutes, I'm going to give you a short overview of this initial proof of concept work, and then I'm going to demonstrate the online systematic conservation planning tool and platform that we've been developing to give you a little flavor for the potential work that we can undertake. To start, this is a fairly lengthy slide, sorry for that, but I think it's important to start with the overall design criteria for this proof of concept. What are we aiming to achieve in the work? So the first design criteria is that the tool can be used to directly support national policy commitments. So these are commitments from national policy documents that are often linked to the international conventions, the Convention on Biodiversity and the United Nations Framework Convention on Climate Change, as well as commitments to the Sustainable Development Goals. The tool should also be able to prioritize or plan for multiple actions, including forms of protection, forms of sustainable management, and forms of land restoration. It should also be able to harness expert opinion and stakeholder values. So it's not a tool only driven by the spatial data inputs, though that's an important component, but so are expert opinion and the values of stakeholders. And I'll show you later on in the tool where those other forms of knowledge come in. It also should use the tools and the concepts of systematic conservation planning, which is basically a quantitative tool-based approach to making land use decisions that can maximize conservation objectives and values. The tool should be spatially explicit, harnessing spatial data, and it should be national level, working to identify indicative essential life support areas. So not necessarily precise locations to deploy specific problems, but rather indicative areas which are important for multiple life support processes. It should include hard constraints on the land base. So what is it possible to do where, as well as soft constraints such as, well, how costly might it be to take action in one place versus another? It should use national data sets wherever available and global data sets where they are suitable. And finally, the tool should be flexible, allowing an exploration of how results change under different scenarios before producing the final essential life support area map. So we're not aiming to immediately produce essential life support area maps, but rather to deliver a flexible tool which can be used to work iteratively towards these final maps. So I think there's a question that we need to address in the beginning, and that is, well, why do we need to use systematic conservation planning tool to help with land use planning decisions? Is this really something that we need to optimize for and use a computer-based approach? So to address that question, I just want to show you this very simple landscape and have you go through a thought exercise with me. So this is a landscape where you're the land manager making decisions about how to create a protected area network in your landscape. You have a simple landscape. It's only 300 pixels, so 10 rows by 30 columns. And in this landscape, each pixel you could choose to either protect it or not protect it. And in so doing, you create in your landscape a network of protected areas. And on this screen, I'm showing you one potential network where the dark green are pixels or planning units where you've chosen to protect, and the lighter green are ones which you're not protecting. Now, this is one protected area network, but there's many others you could choose to create instead. Instead of protecting these planning units, you might choose to protect these ones over here, or maybe some down here, or up in this corner over here. So the question is, in this incredibly simple landscape, how many different unique networks of protected areas could you conceivably create? Is it 300 different types of networks, 3,000, 3 million, or even more than that? I think the answer will surprise you. The number of different protected area networks you could place into this landscape is 2 with 90 zeros after it. So I can't tell you what this number is. This is such a large number, it has no name. But this number is far greater than the total number of atoms in the entire universe. So the number of different unique ways you could create a protected area network in this landscape is greater than the diversity or the number of atoms in the known universe. So we can think about land use decisions as being simple, but actually it's such a complex decision space that really, especially when we're thinking about multiple objectives like carbon and biodiversity and people's livelihoods and disasters, as it becomes, and bigger landscapes. You know, this is a very simple landscape, but in the case of the projects that we're developing, there's tens or even hundreds of thousands of different pixels. And really having a software that searches out optimal solutions in that landscape and presents them to us to evaluate really can have benefits. And this is especially true if you're talking about multiple actions. We're not only talking about protected areas, but we're also talking about, for instance, these yellow areas might be areas which are important to sustainably manage for agriculture, forestry, or other land uses. And blue might be areas where restoration activities might be a priority to restore forests or reduce land degradation, desertification. So even once we start talking about these more complex, bigger landscapes with multiple actions, the benefits of using a tool increase. Okay, so here, this is an overall diagram of the essential life support area process and how it all fits together. It's quite complex, but I'll just show this to you quickly now so you can get a sense of the overall process and the different moving parts. But it's something that you'll see again and again, and we'll explore in more depth the different parts of it throughout the workshops and the continuing work. So the overall idea is that we're looking to support national policy commitments. And these commitments are often influenced by international conventions and the Sustainable Development Goals. So within national policy, there's often commitments to actions. So how much protected area expansion is a country committing to, or how much action for restoration or land management might be your country be committing to. So there's actions coming from the policies, as well as preferred outcomes. So this might be to achieve things like species conservation or the improvement in water quality or people's livelihoods or adaptation to climate change. And these nature-based solutions or outcomes really come from the action. So these are kind of two different but related work streams in the essential life support area. So for the actions, to move towards spatial planning, we need to acquire data sets about what controls where those actions are possible. First, what are the actions? But then what are the hard constraints? Is it really not possible to restore agricultural lands because those are important for food provision or export crops? Where might protection be possible versus impossible? So moving from a definition of what the actions are from the national policies to actual spatial data to help define where those can occur. And then down the preferred outcomes, this is the nature-based solutions that we're looking for. Again, we need to look for data sets that could reflect those. So where are species and ecosystems located? Where are people dependent on natural systems for their livelihoods or to buffer them from disasters? And then this is where expert review and stakeholder weighting come in. So it's important that as we gather these data sets that we put them together and present them to national experts to ask, are these data sets reflecting the patterns that you believe to be true in your country? Or are some things missing? Are there any gaps? And then through this expert review process, we can go back and improve the data sets. And this could be an iterative process, of course. Also, the preferred outcomes, what we're finding is often in national policy, there's a listing of what a country would like to achieve from the nature-based solutions, but not necessarily a weighting of which ones are more important than others. And this is important because once you're talking about multiple objectives, often those objectives might have trade-offs between them. And it's important to get national stakeholder and expert weighting of which outcomes are more important. And then right in the middle here, this is where we have a definition of how actions influence outcomes. So if you are to protect land, what's that going to mean for food provision? And in reality, protecting land often results in a negative impact on food provision because protected land is often not used for growing agricultural crops. However, protection might, for instance, improve the condition of biodiversity in the ecosystem. So it's important here that we identify how actions influence outcomes. And then all of these different things, the actions, where they can occur, what they do for preferred outcomes, and how those outcomes vary across space. All those come together into the ELSA action mapping tool. And I think at this point, I don't believe I have more to present. At this point, I can move to a demonstration of the online tool. Okay, I'm now going to give you a demonstration of the pilot tool for Colombia. What we're looking at here is our shiny interface that controls the tool. And on the back end, we have an optimization, spatial optimization running on a server. Now, in the case of Colombia, we were a little bit ambitious, and we actually used 1 million planning units, so 1 million independent decision units for Colombia to summarize all the spatial data, which is far greater than what we used in other countries. Which has presented some new challenges, and we actually don't yet have this pilot tool running on a server. Instead, it's running locally on my desktop here where I'm working. So there are two ways to run the tool. One is locally on your computer, and the other is through a web browser to a server sitting somewhere. I also just noticed that we spelled Colombia in the way that we do in our province here, British Columbia, instead of as Colombia. So sorry for that spelling error. It's something that I do habitually because I'm so used to spelling British Columbia. Okay, so the idea behind this user interface is just to make it a lot more accessible to run this spatial planning for the essential life support areas. So a policymaker or a member of the public or a different institution can access this tool, and everything's done through a simple click interface. Normally when you're running this sort of a tool, almost always you're running it in a coding language that's really only accessible to experts. Whereas with this tool and the pilot that I'm showing you, the idea here is to create something just more accessible to a wider diversity of users. So I'm just going to take a few minutes to take you through the basic functionality of the tool. And this is just to give you a window into how this could operate for Colombia. Again, this is a pilot tool with very preliminary data. So please don't look too closely at the data sets we've used. Really, throughout these workshops, the idea is to get a much better idea of the important nature-based policies in the country, as well as the spatial data sets that can inform those policies. And then it's really in the version 2 of the tool where we'll have far greater data, and we can look much more closely into the actual areas being highlighted in the tool. So right now, I just want to show you the functionality. So here, these 5 tabs are some of the basic inputs and outputs for the tool. So this first tab is where you edit the weights for each of the input data sets. So you can see here, we've we've populated this pilot tool with 12 data sets for Colombia. So data sets on connectivity, endemism, important or key biodiversity areas, as well as maps for key strategic ecosystems, as well as a number of data sets on biomass carbon, so forest carbon, as well as soil carbon. I mean, some of these data sets are national data sets, and some of them are global data sets. So the way the optimization works is it optimizes the placement of essential life support areas based on the data sets that you give it, but also how important the data sets are to you. So right now, each of the weights given to the data sets are the same. And we're telling the tool, well, each data set is as important as the next. But you could say, well, actually, I care a lot about species. So I'm not so worried about connectivity, but species endemism and key biodiversity areas and species richness are really important to me. And strategic ecosystems are not. And carbon's also very important because I'm going to keep all of these as a 1. So here I am changing the weights going into the tool, or I might even say soil carbon is a 2. It's more important than anything else to me when I'm identifying essential life support areas. So there is this expert and stakeholder input into the tool where you weight one outcome against another. So that's listing of the data sets as well as the weights given to them. And we can actually now, Colombia is the first country where we've added this functionality. You're able to review all of those input data sets independently. So I go to this tab here, the input layers. I can click on all the different data sets that are going into this pilot version of the tool, and then later the more detailed versions, and you're able to view the data sets so you understand what's driving the spatial planning and the optimization. So that's just nice additional functionality that hasn't been there yet for the other countries. Is being able to view each data set independently. And then if we move over here to the results map, and we click on this, what's happening right here, it's asking us to wait because it's doing a GIS process where it's actually taking all the individual input layers and it's applying the weights that you gave the tool. So for some of them, we have weights of 0, others 1, others 2. It's weighting the inputs to create an overall opportunity map for the country. So we can zoom in, and right now we're displaying the overall opportunity map for the whole country, or we can break it out by different themes. So we can break it out focusing only on data sets related most closely to biodiversity. So those were the species data sets that we were looking at. So this is the heat map for biodiversity based on the inputs that we gave the tool and the weights that we gave it. And we could look at the input map for carbon. So this is the biomass carbon and soil carbon weighted particularly high. So you're able to zoom in to these layers and also view underneath the aerial imagery. So you can zoom into different parts of the country that you recognize, look at the imagery, and you can overlay the heat maps to see how they overlay with what you could see through satellite imagery. Just again, helping to interpret the data sets and provide expert input into what we're viewing. So these heat maps tell us overall how important different parts of the country are for the different policy commitments and the different weights that we've given the tool. But it doesn't actually tell you where action is possible and where the action would be optimal to meet policy commitments. So this is overall opportunities, but it doesn't tell much about where areas would be good to protect or to restore or to sustainably manage, those actual actions on the ground, which are constrained by other things. So that's the next step in the process, moving from opportunity maps to actual action maps for protecting, managing, and restoring. And the functionality to get there is on the left panel here. So ultimately, when you're ready to run the optimization, you can click this button and the optimization will run. But first, you need to set the basic parameters. So the first parameter that you can set is how the tool should consider cost. So if you leave it at area year, you're telling the tool to treat all areas the same in terms of how much it costs to take action there. So it's basically ignore cost. Or you could choose to use the cost layer for the project. So for the pilot project, we've used human footprint as the cost layer. So this is the Colombian human footprint, which is just published last week. And basically it's a measure of total development, the number of people in a landscape, the number of human land covers, infrastructure, road networks. And you're telling the tool that to take action to protect or restore systems, natural systems, it's more costly to do that where there's high levels of human development, right? That's kind of intuitive. So you can tell a tool to consider that cost and to try and minimize the cost of taking action, in which case you use the cost layer or you can go without. The next thing to tell a tool is how to consider existing protected areas. So you could lock in all existing protected areas. So this is the entire current national network of protected areas. You could say, well, essential life support areas must build off and include all existing protected areas. And then you set quantitative targets for expanding protected areas, taking action to restore natural systems, and finally, taking action to sustainably manage systems, which could be sustainable agriculture or sustainable forestry, like reduced impact logging techniques and forest certification. So you could set each one of these. So you might want to meet a 20% national protected area target and a 10% restoration target, and let's say a 10% sustainable management target. Once those are all set, you hit run optimization. Now in the case of the Colombian project, again, because we've got this 1 million planning units, we think it's going to be really good for Colombia to have a more resolved spatial data, much more spatially precise. But the server is having trouble running at the moment. So I'm going to switch over here actually to the Peru project, which has fewer planning units, and show you you can hit run optimization and the algorithm will run, and then you're able to click on the actual essential life support area action map. So you're, again, sorry, I'm showing you for Peru for the pilot. But the basic functionality is the same for Colombia. It's to identify areas in green, which are essential life support areas to protect, in purple, essential life support areas to restore, and in blue, essential life support areas to sustainably manage for Peru's pilot. So this is what we call the essential life support area action map. And like the opportunity maps, you can also overlay the aerial imagery and zoom into the maps to look at how these areas overlay with what you can observe on the ground. So my purpose here was just to give a little bit of an introduction to how this tool operates. It's not to actually show the real opportunity maps for Colombia or the essential life support area action maps, because really to get there, we need to do the policy review, we need to do the data hackathon, we need to understand what's important and what information is available, and then get the best available data into the tool to actually identify the essential life support areas. But hopefully this gives you a bit of an introduction to how the tool looks, how you can view independent data sets, how you can tell a tool what's important to you, how you can run the optimization, and how you can view the outputs. And the final thing to show you as part of the tool is how to download and bring information out of the tool. So things aren't only housed here. You can come to this results and download, and you can download a raster file that shows you the opportunity maps and the essential life support areas maps. And you can also download a summary table which shows you how well you're meeting policy commitments, and bring that information into your, say, Excel for your database or your GIS platform. And the final thing to note is, while we're only interacting here with a user interface, ultimately the objective will be to do a full transfer of the tool, so that you have access to all the underlying code, how everything's run, as well as the underlying spatial data set as well. So it's not just a black box and user interface.